That's what I thought.
Okay.
Now, do you remember the last time we were together, what we were talking about? Anybody remember? Okay. Last page of your note sheet, back side, problem number 21. How many social security numbers are possible if all arrangements are possible? Now, what that means is that we're going to allow every single possible number. So even 0, 0, 0, 0, 0, 0, 0, 0, we're going to allow that. Every single number is allowed. How many are there? Well, you remember. Hey, Katie, we're going now. Okay, so I need focus and attention. Okay. So you remember, I don't know if you know your social security number or not, but it looks like this. If every single possible number is allowed, how many social security numbers are out there? Well, how many numbers could you choose from to put in this blank?
10.
10. There are 10 digits, aren't there? Yeah, there are 10 digits. We have a base 10 number system. There's 10 digits. How about here? No. Every single arrangement's possible. So that would be 10 and 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 10. Now, if we said you couldn't repeat any digits, then it would be 10, 9, 8, and so on. But I know in my social security number, there's a repeated digit. It's allowed. You can have the same number twice. So 10, 10, 10, 10, so a shorter way of writing that would be what? 10 to the 1, 2, 3, 4, 5, 6, 7, 8, 9th power. And that maybe is how you could type that into your calculator, 10 to the 9th power. And
I got a number with a lot of zeros.
Yes, it's a big number. It's like a billion or something.
Dude, I could.
Now,
9 zeros. Is that a billion?
how many telephone numbers are possible in the 317 area code? So assuming that every phone number is possible, how many are there? So
10 to the 7th power.
that would be 10, 10, 10, 10, 10, 10, 10. And that's allowing everything. That would be allowing the number 999, 99999, and 0, 0, 0, 0, 0. That's allowing everything. So that would be 10 to the 7th.
I'm struggling. Okay, so 1 to 10. Why isn't the 10 taking up 2 spaces?
No, there are 10 choices for that first number. That's not the number 10. I mean, that's not part of the phone number. There are 10 choices for that first blank. When you build a phone number, you got it, like my phone number starts with a 5, okay? But there are 10 different numbers that your phone number could start with. And 10 for this spot, and so on and so on. Remember, when we fill in the blanks, it's choices. Maya, it's choices that go in the blank.
Okay.
How many choices do I have for that position? Okay?
Yeah.
All right, now, on the next note sheets, page 58, your new ones, how many 11-letter words can be formed from the letters Mississippi? I think we talked about this, so let's do it again. When we talk about how many new words can be formed, does anybody remember how we start?
Count how many multiples you have.
No. First we count how many letters we have. Yeah, first we just start with how many letters do I have? How many letters are there in this word? So I start with 11 factorial. So if there had been 8 letters, I would start with 8 factorial. Whatever number of letters you've got, that's what you start with. But then what's special about this word? There are repeaters. So we divide by the repeaters. So we've got 4 S's, so we'll divide by 4 factorial. That takes care of the S's.
And then 4 I's.
There are 4 I's, so we have to divide by another 4 factorial. And 2 P's, so we divide by 2 factorial. Now let's type this one in on our calculator. By the way, you are dead meat if you don't have a calculator, because there's no way you're going to be able to do all this arithmetic in your head. Okay? So let's get our calculators out. And do you remember on whatever day we were last together when I was talking about this, that we must put that denominator in parentheses if it has more than one thing in it? Okay, so I'm going to type that in too. Let's see. For those of you who forgot, where do we get that factorial symbol?
Math, and it goes to the
Math,
far right,
over to
PRB.
prob, and then down to the symbol.
PRB, yeah.
So here we go.
So sorry. Did you have fun this weekend? 440?
I got 34650. Let me know if you match that.
Yep.
Not right here. Okay, anybody match that number?
Yes, ma'am.
So you should be able to handle any word I give you, right?
Yes, ma'am.
So if we took a word like Dane's name, how many 5-letter words can I form from those letters? What do I start with? 5 factorial. And that would be it, because why? There's no repeaters, right? No repeaters. Okay? All right. Number 25. Explain why at least 2 students must have the same first and last initial at Cathedral. So for example, my initials are LF. That's what we're talking about. How do I absolutely know that somebody out there has to match? They don't necessarily have to match me, but somebody has to match out there. There have to be at least 2 people that have the same initials. How many initial combinations are possible?
26.
26 times no. 26 times 26. Could it be possible to have MM be your initials?
Yes.
Yeah, does anybody in here have that?
What?
That would be Maya McLaurin, and she's an MM right there.
The top.
So 26 times 26, what is this number? Okay, Patrick Troy, there are 676 possible initial combinations. How do I know absolutely people at Cathedral have to match? Because there's 1,300 people at Cathedral. And if there's 1,300 people, but there's only 676 combinations, what does that mean? Somebody's got to be repeating, right? Now that doesn't mean there's another MM or another LF. It just means there has to be somebody out there matching, because there aren't enough combinations to cover everybody. In how many ways can a club with 20 members choose a president and a vice president? Now, this is something new today, boys and girls, so I need everybody to pay close attention, because in this unit, this is probably the trickiest part. I want you to read question 26A, which I already read, And then I want you to read 26B, and I want you to tell me what the difference is.
Quick question, back to 26 was.
There's only 676 possibilities, but there's 1,300 kids. Okay. Can somebody, you've all had a chance now to read, I want you to read 26A and B. What is the difference? Patrick?
In A, you have to elect some, but there has to be a majority for president, right? Or the president has to get more votes, but B, there's have to be equal.
You are very, very close. You are very close. Let's, Ron?
In A, it's talking about how many different ways people can vote for president, and then in B, it's like how they go about choosing a president.
Kind of.
Or foul ball, or
I want you to think about it. Yeah, it's a foul ball. You made contact, but you didn't quite get it in bounds.
close enough.
Okay. Now, let's think about this for a second. In problem number A, I am going to pick Abby for president and Dane for vice president. Or I could pick Dane for president and Abby for vice president. In problem A, does the order that I pick the students matter?
Yes.
Yes, because whoever I pick first is going to be president. Now look at problem B. Does the order I pick the students matter? In problem B, does it matter if I pick Abby first or Dane first? No, what matters is they both got picked, so they're like a committee. They don't have assigned jobs, president, vice president. They're just the group. When order matters, so 26A, order matters. When order matters, you have what we call a permutation. This is important. It is the key to a big chunk of this little unit. A permutation implies that order matters. When I have 20 members and I'm going to pick 2 of them in order, it's 20P2 or P22. It's written both ways. This means the number of permutations of 20 things, in this case people, taken 2 at a time. That's what this means. So in problem A, order matters. I have 20 kids, I'm picking 2 of them, and the order matters.
So if it said 40 members,
It'd be 40P2. We're going to do some more. Let's just hang loose here for a second.
right,
Permutation. Order matters. P. I don't know if you paid any attention on your calculator, but I want you to type 20, and then I want you to go into your math prob menu just like you were going to do the factorial symbol. Do you see, on my calculator, it's the second one down, do you see this button? That's your permutations button. So you already pressed 20, or at least I told you to. Now press that button and press 2, enter. The answer is 380. Did you get 380? Press 20, then NPR 2. And NPR is in the same place as your factorial button is. Now, question B is exactly the same thing, kids, except order doesn't matter. I still have 20 kids, I'm still choosing 2, but the order doesn't matter. No order. That's called a combination. And it is written 20C2 or C22. I still have 20 people and I'm still picking 2. But now the order doesn't matter. When order doesn't matter, you use C. You type that in exactly the same way. Press 20, go to your Math Prob menu, and you'll notice you have an NCR button. NCR button. Press it. And the answer to that one is 190. When you read a problem that involves, okay, I got this many things and I'm going to pick this many, I got 18 things and I'm going to pick 5, what's the one question you have to ask yourself? Does order matter? Because if there are 18 things and you're picking 5, it's going to be 18C5 or 18C5. And the one you pick depends on whether order matters. Let's try another one. Look at 27. In how many ways can a club with 13 members choose a 4-person leadership team? As opposed to question B, which says, in how many ways can the club, same club, 13 members, pick a president, vice president, secretary, and treasurer? Do you see both problems, A and B, involve 13 people, choose 4?
Yes.
One of them's a P and one of them's a C.
First one, C.
First one C. And why is the first one C?
Because it doesn't matter about the order.
Because the order doesn't matter. There are 13 people and we just want 4 of them to be on our team. Who cares who gets picked first? Let's type that in, get an answer, 13C4.
715.
We got it? You are fast. Yep, it is, 715. Oops, 715. Now look at question B. Still 13 people, still choosing 4. Does order matter? In question B, it matters because the first person I pick will be president. And the second person I pick will be vice president and so on. So question B is 13P4. Which is 17160. Okay? Now, I want to give you, we're going to have a quiz tomorrow, but to help us with that, I've got a practice quiz.
Thank you so much.
This is the quiz I gave last year. Yours is going to look just like this.
Thank you. It's actually very soft.
All right, here we go. Oh, I'm sorry. All right, now, this is going to be good review as we go through these problems because we talked about this a long time ago. I mean, last, Thursday or whatever. All right, so here we go. Oh, not number 1. We've already talked about that. What's the answer to problem number 1? What would it be? 6 factorial. And on your quiz, I'll ask you to work that out, so you know how to do that. 6 factorial is 720. Now, I want somebody to explain to me how we got 6 factorial. 6 letters, none of them repeat. Bingo. Everybody okay with that? Thomas Berg, 6 factorial. You got it? Everybody okay? All right, number 2, same idea, but what's different? You've got some repeaters. Step 1. What do we start with? Count the letters. How many are there? So we start with 5 factorial. Kids, however many letters there are, that's what you start with. There are 5. Now, what do I need to divide by? 2. 2 factorial, because there are 2 I's in the word. So what's that going to be? You guys are way faster than I am. 60. So far, so good. So if we have a quiz like this, these questions tomorrow, we're going to get them right, right?
I'm going to boot this quiz tomorrow.
All right, number 3. In how many ways can I award a first, second, and third place ribbon to 3 different students in a class of 15? Now I want you to think about this for a minute. There's 2 ways we can do this. What do you think? 1, oh, I heard both options, and both of them are perfect. Both of them are perfect. So one way to do the problem is to draw a picture of it. And when I say draw a picture of it, I mean, here's first place, second place, third place. How many choices do I have in a class of 15 for first place? 15. Now somebody's won first place, so now there are 14 and then 13, right? So let's multiply those together and let's see what we get. 2730. Now, Gibran said, and I really, really like this and want everybody paying attention. Gibran said, wait a minute, Mrs. Ford. There's 15 kids and you're going to pick 3 of them, right, to give awards to? The order you pick them matters because somebody's going to get first, second, and third. So order matters. So if there are 15, I'm picking 3 and order matters. I could set this up as 15P3. Type that in on your calculator and guess what you get?
2730.
You do. You can do the problem either way. Number 4. How many different committees of 4 can be selected from a class of 12? So you have 12, very good, Tyler. You've got 12 kids and you're going to pick 4 of them. You're making a committee. Does the order you pick them matter if you're just making a committee? No. So that would be 12C4. Yeah. And 12C4 is, oh geez. Some days it's the pit's getting old. 495?
Yeah.
Anybody got an idea about the last question?
Yes, I do.
6 factorial. We talked about this, one of the key ideas of the chapter. There are several key ideas. One of them is, if you are arranging 6 things in a row, that's 6 factorial. If you're arranging 8 things in a row, it's 8 factorial. Okay? Now, I have one new thing to talk about. And then, we'll look at the next few. There's one little piece of this that I need to talk about. We just said, if we arrange 6 things in a line, or in a row, it's 6 factorial. What if we arrange those in a circle? What if we were putting the 6 people around a dining room table or around a campfire? Any idea?
There will be 6 options. I'm just
Yeah,
not
for that.
Yeah, well, and then it should be 6 options. Because anyway,
What was the
you can
question?
always rotate it.
Well, it comes down to the rotation idea.
Rotation's key.
Yep, because a circle, okay, when you arrange people in a line,
Rotation's key.
when you arrange people in a line, there's a beginning and an end, right? When you put them in a circle, though,
There's no beginning.
here are your 6 people. There are your 6 people. There is no beginning and no end, right? So if we had people A, B, C, D, E, F, it wouldn't matter where we put A. I could put A here, and there's B, C, D, E, F. But we could also put A here, and that would be the same arrangement, right? Just rotated.
Yeah.
So when you put 6 things in a row, or excuse me, in a circle, it's 5 factorial. There's always one less, and that's because this pattern gets repeated 6 times. There are 6 rotations of this pattern. So if we divide 6 factorial by 6, we're just left with 5 factorial. I know that's a little complicated. Let's just understand, or let's just know that if you arrange a number of things in a circle, it's 1 less factorial. So 8 people in a circle would be 7 factorial. 8 people in a row would be 8 factorial. Okay, Kieran, you need to put your head out. Okay? All right, so everybody's clear on the quiz tomorrow. We'll be over that kind of stuff. We're gonna talk about something else now. But the quiz tomorrow is over that stuff.
Just to be clear, factorial is like 6 times 5.
Yep, yep. But I don't want you typing that in on your calculator. I want you using your factorial button. Right, so you have time to get everything done. All right, before I go on to the next thing, did anybody do the homework and have a question? Okay, then the next thing we're going to talk about, total switch gears. So that, I need everybody to understand, the quiz tomorrow, we've talked about what's on it, all right? What I'm getting ready to do is the next step, which is not on the quiz tomorrow. All right, so here we go. What is the next step? Well, if you look at your note sheet, that looks like a totally different problem. It says expand x plus y to the 4th power. Okay? Now, I don't want you writing this down. I want you paying attention. Because we're going to figure out how to do that without foiling. I do not want to foil x plus y, x plus y, x plus y, x plus y. Okay? So here's what I want you to think about. Everybody in the room, again, you do not need to write this down. I will get to a point where you'll want to start writing stuff down, but right now I just want you to see if you can figure this out. A plus b to the 1st power, everybody knows that's a plus b. If you do a plus b to the 2nd power, though, that's a FOIL, so you get a squared plus 2ab plus b squared. That, you know that, right? That's pretty obvious. Now, what if we did it to the 3rd power? Well, I know that's a cubed plus 3a squared b plus 3ab squared plus b cubed.
You know that. That's
I know that, yeah. I got that by foiling a plus b times a plus b times a plus b. A plus b to the fourth
Oh my
is
God.
a to the fourth plus 4a cubed b plus 6a squared b squared plus 4ab cubed plus b to the fourth.
Okay, all right.
Now, Gibran is up here, his brain is getting ready to explode, and he is so impressed with how smart I am. But here's the deal, folks, I am not smart. There's a trick to this.
There's a trick.
There's a trick.
I'm not
And
smart.
you
The
need
trick
to
is
help
just 14 lines.
figure out the trick.
I know pre-cal at the back of my hand, but I'm not.
Because I can do the next one. I do not have this memorized. I'm just doing this using the trick I know, and I gotta quit talking or I'm not gonna get it right. And I want you to tell me what you observe. Now, some of it is really easy. So Maya Brownlow, if I said to you,
Oh, I got it.
all right,
I got
shut
it.
up a minute. We're going to do a plus b to the sixth.
Back up.
Now, Maya, I want you to look at, just tell me anything at all that you observe. A plus b to the first, a plus b to the second, a plus b to the
A to the
third.
sixth.
So you're going to have an a to the sixth on the beginning, and a, what's going to be on the end?
B to the
A
sixth.
b to the sixth.
Girl, don't mess around with a Harvard. Don't mess
Okay.
around with a
So we made that observation. Now,
I don't got no more answers.
do you notice anything else? You don't have to know the whole thing, but do you see anything else that's happening?
Hold on, let mine take over. Take the wheel.
Okay,
Jesus
so
take.
Dane says, it looks like the next one will be 6a to the fifth, b to the first,
Get hype. Get
and
hype.
the next one will have an a to the fourth, b to the second. That's not right. No, it's not a 12. We'll talk about that in a minute, but it's not 12. Let's just worry about the letters for a minute. And the next one will be a to the
Third,
third,
B to the
b to the third.
then A to the second, B to the fourth, A to the first, B to the fifth.
And then I'll be to the sixth one on the end.
Okay, so as A goes
Now.
to the left of
Maya Brownell, or Maya McClure, quit covering your eyes. This is good stuff. You can see that as you go from term to term, we start with an a to the fifth, here for example, but then we go down to a to the fourth. Jordan, put your feet on the floor, sit up straight so you can stay awake. Then we go down to a cubed, a squared, a, and finally no a's at all. So as the kids were helping me put this together, they said, okay, we're going to start with a to the sixth, and then we'll go down to a to the fifth, fourth, third, squared, a to the first, and no a. What happens with the b terms?
it goes up.
Same thing, but this way, right?
What?
Those are the exponents.
Oh.
Now, what we're missing are these coefficients in here. We haven't figured out what those are.
Yeah, I don't.
So that's what we need to figure out now. Ms. Brownlow, did you have a?
Is this one problem? We don't have to do all this?
No, you're gonna go straight to whichever one is asked for, okay? We're just trying to figure out how we're gonna do that.
Would that be 16 or
No.
No.
Here's what I want you to do. I want you to, everybody good with the letters?
It's gonna be 12.
No, stop, don't guess. Everybody good with the letters?
Yeah.
Okay, so now we're worried about the coefficients. So we're gonna go back and we're gonna look at just the coefficients now. So in the first thing, we had 1 and 1. Then we have 1, 2, 1. Then we have 1, 3, 3, 1, 1, 4, 6, 4, 1, 1, 5, 10, 10, 5, 1. Now, that's down to here. Those are the ones I did for you. Your job is to figure out, okay, you know this is a 1 and this is a 1. You already told me that.
6.
This one is a 6 and this one is a 6. You didn't tell me that one yet, but you can see that. How about those middle ones? Can you see what's going on? See this 10 right here? It came from adding the 4 and the 6. So Ethan Topham says this number must be a 15. He is right on. It's a 15.
So in order to know that,
What's this one?
20,
And this one is 15.
so in order to
So the coefficients would be 15, 20, 15. Now Jabron is getting ready to say, doesn't happen very often, but he's getting ready to say something really powerful. So I want you to listen.
that was okay. But in order to know that, that means you'd have to know the first one too.
Exactly. Jabron said, wait a minute, Mrs. Ford. If I wanted to fill, if this had been the question, if this is what I was doing, then I would need to know this row above it, because I used this row to get this row, right?
Wouldn't you need the row above that to get Miss Ford? This is.
That's what I'm saying. She low-key played us. This ain't Precal. You trying to play me? I'm not about to be straining my brain muscles for this.
Don't go to 6. Don't go to 6 every.
Now, what I want you to do, remember I said you didn't have to write anything down. Now I'm ready to have you write something down. On your note sheet, I should have left space and I didn't, but try to find a little,
Miss Ford,
Reference.
me and Olivia looking down this question, we found something that you're really trying to add numbers in it too.
we're going to. Yeah, honey, we're going to. We're going one step at a time.
That's right, honey. You're gonna fail.
On your note sheet, maybe over here to the side, you're going to need quite a bit of room, but maybe over here to the side, I want you to write that triangle of numbers that I had on the board. That is called Pascal's Triangle.
Can you put that on the quiz too? Extra fun.
This is not on the quiz.
So,
Blaise Pascal was one of the great mathematicians. In fact, there's a language, computer language named Pascal, named after him. You should do some reading about him. I'll talk more about him when you do probability. But he's a pretty fascinating guy. Very weird, like most of the great mathematicians. Anyway, here it is. Starts with a 1 and a 1. Katie, you need to write this down. What is the next row? We start with 1 and 1.
1, 3, 3, 1.
No, 1, 2, 1.
It's right there.
Every row starts and ends with 1. The numbers in between are found by adding the 2 above it. So this is going to be a 3, and this is going to be a 3. We start and end with 1. What will this next one be?
4,
4, 6, 4. Now you've got to be organized and you've got to be neat or you're going to be adding the wrong things. We start and end with a 1. So what would go here? 5,
7, 10. Oh, I get it now.
and we'll do one more row. What's the sixth row? Be 1,
6,
15, 20, 15, 6, 1.
Quick question.
Now, we're going to have that written on our note sheet. It will not be written on your test, though, so you need to make sure you can build this.
Okay.
We start with 1 and 1. That's the beginning. And then every row starts with a 1, ends with a 1, and the number in the middle comes from added.
Quick question. On a test or a quiz, realistically, how many powers will you fill out? Would you give us like have to like expand x plus y equals 20?
Okay, that is a very fair question. Jabron says, well, I have to do x plus y to the 20th power. And the answer is, you might have to find a single term of that. But there's a trick to the triangle that I haven't showed you yet. So I'll do that if that's okay. Okay? But I need to take 10 minutes. I haven't done that yet. Thomas, will you turn the video off, please? No. See our holder.